Okay, so here's how you perform integration by substitution. First of all, we've been talking about this a lot. The power rule, which is the only rule we have for integration, is this. And you can string together x's, you can make this a sum or a difference, and you can factor out constants. So that helps a little bit. But if you look at this, and if I just said, what if we want to integrate u to the n with respect to u? Would this be true? And the thing is, the only difference between this and this is the variable. Instead of using x's, I'm using u. And this is key. U to the n, and you have to change this variable too. Dx becomes du. But then really that's all it is. You're just changing x's to u. So of course the result would just be the same thing except with u's. And that's what u substitution comes down to. And that's how easy it is. We're not making up anything really new, but the whole work is trying to get a function of x changed into a function of u like that. So here's a quick example of how you would do that. This goes back to, if you watch the last video, we looked at all of these and we saw that this is one we definitely could not do with our basic power rule. So now we're going to use u substitution. So it's pretty simple. However, might be confusing at first, so you may have to look at a few examples. But here we go. We can only integrate now either x to a power or u to a power. So I'm going to try to get it into this form, u's, because I know we know we can't integrate this as x to a power. So see this 2x plus 1 and notice that's an inside function. That's usually what you're going to make u. And by making u, you just make it u. You say, all right, let u be 2x plus 1. So now we need to get a dx involved because we can't have this being u and have a dx. We need a u and a du. So to bring du into it, this is how we're going to think of it. Take the derivative. So if u is that, du dx, the derivative of u with respect to x, is 2, because the derivative of 2x is 2. So now multiply both sides by dx. And usually we're going to skip this part. We'll just say du would be the derivative of this, which is 2 times dx. So we have this and this. So now we're going to rewrite this integral using these two boxes. So in other words, we have the integral of the square root of 2x plus 1 is u, dx, which is right here, would be equal to dx equals du over 2. So this dx, I can write du over 2. Then we're going to factor out 1/2, because we can. And that's it. That's what the u substitutions give us. And that's easy. It's an easy power rule, which is what all your integrals are ever going to be. You just have to be able to get them in that form. So now I'm going to integrate. Add 1. Multiply by the reciprocal. 1/2 times 2/3 is 1/3. U to the 3 halves. Make sure you plug the u back in. So remember, we said u is 2x plus 1. So the last step is to plug that back in. And since I'm done, I'm going to add my plus c because it's an indefinite integral. And that is the integral of the square root of 2x plus 1. Now, to check that, you check it like any integration problem. You find the derivative. So I'm going to do that. The derivative of my answer, 1/3 2x plus 1 to the 3 halves plus c. It's a chain rule. So bring down the 3 halves. 3 halves times 1/3 is 1/2. Leave the inside alone. That's what we do with the chain rule. Subtract 1. And then multiply by the derivative of the inside, which is 2x plus 1. So the derivative of the inside is 2. And then plus the derivative of c, which is 0. Simplify. 2 times 1/2 is 1. We're left with just the square root of 2x plus 1, which is our original integrand. So it checks, meaning we did it right, and that's it. So we're going to do some more examples because you probably won't get this maybe after the first one. You may even want to re-watch this video, rewind it, and then get a good understanding of it before we look at the next problems.